Hi. So, on a couple of occasions, people who wish to remain anonymous have asked me, Alex, what's the connection between code and a video game? Well, let me answer you, Victor. Oh, shit. So, what is the connection between code and a video game? Well, imagine you have a blank canvas and a cutout of a character that you want to play around with. What you would do first is make the computer display your character on the canvas. So you would tell it the X and Y coordinates where you would like to place your character. Now you have a not very exciting game where nothing is happening and your character is being displayed in a single place. What would make it exciting? Well, the ability to move the character, of course. So you add some code that would wait for the user to press specific buttons on the keyboard, say left and right arrow keys, and if the player presses right, you want to increase the X value of the position of the character, if left, decrease. Cool. The problem is, computers in general are stupidly fast, and without a limit to the number of times that the computer will update the scene, things will quickly get out of hand. That is to say, the character will quickly end up off screen. So you want to limit the number of times the scene is updated, to say 60 frames per second. Awesome. However, when the character moves around, it doesn't look particularly interesting. There's no animation. Which means that this is a perfect time to add a sprite sheet, which essentially defines the different frames that would make up character movement. Then you tell the computer how long for you want every frame to be displayed, and the order in which it should cycle through them. You would define different frames for different behavior. Here I've made a sprite sheet for our little guy. This row is him walking, and I can just tell the computer to mirror it if the character is walking in the opposite direction. Here is a sample of a sprite sheet with more movements. Speaking of which, now we can walk, but you know what's even cooler? Gravity. So we add a bit of code that will decrease our guy's Y value when we need to fall down. Gravity seems to work all the time, so that's how it should work in our game as well. It should constantly push the character down. The problem now, of course, is that our character falls off the screen. So we need to add some stuff for them to walk on. Let's do the same thing over again, do a cutout of the ground and stick it on the screen. And it doesn't work. We kind of know what we want it to do because we know the context. The computer doesn't. So what we can do is draw an imaginary rectangle around the ground and another one around our character, and then every time we update the character's position, check if the rectangles are intersecting. That's collision detection. If they are, we should stop falling. We can apply the same logic for enemies, collectible items, etc. Let's also add a background and position it behind everything. The computer draws everything in order, so we need to arrange everything correctly, just like if we stacked picture cutouts on a real canvas. So we draw the background first, then the character, then the ground, or the ground, then the character, who cares. We might want the background to consist of several layers, which would add depth. That's something parallax scrolling is great at. We just add 3 different layers of background and move them at different speeds as the character moves around. Oh, which reminds me, all modern game dev libraries that I came across already have a definable camera, so you can just attach it to your character and it will move around as your character does. But if you're going old school, it might look like your character is moving on screen, but actually what happens is everything else moves in relation to your character, giving an illusion of it happening the other way round, which blew my mind the first time I found out about it. And that's a good place to stop. Thanks for watching.